Hello Grinners, welcome to another Unreal Engine tutorial where we are going to be building a music visualization tool, a blueprint that we can drop into any one of our games and visualize some music, and it's going to look a little bit like this. All right, let's get started. We're going to start off by using the third-person template provided by Unreal just to give us a world in which we can put our audio visualization. I've already created a few things to get us off the ground here. One is I created a very simple material which just has a base color and an emissive strength. And from that, I created a material instance that is sort of a shiny white substance. And that is being applied to this blueprint that I've already created, which is just a cube. The cube is quite small there. I can actually just make it the default scene root, and then we can see it. And it has the material that I created, that emissive color applied to it. And it's going to be these cubes that are going to make up the various components of our visualization. I've also got a blueprint created but not completed for this visualization. So it exists right here in my blueprints folder. It's called BP Sound Cube Visualization, and I've mapped out what we need to do in this particular blueprint. One thing we're going to need is we're going to need an audio component. I'll drop that in there and I'll just leave it named audio. And then there's going to be a sequence of events that's going to be triggered on begin play. And the very first thing we're going to do is we're going to enable player input. We're going to let the player interact with this blueprint by way of the keyboard. We're going to give the player the ability to play and pause music when they hit the letter P on the keyboard. To enable that, we need to hook up some music to this audio source. We need to spawn a number of audio cubes. That's these BP sound cubes. We're going to spawn a total of 48 of them, and I'll explain why we're using that particular number as we progress. And then last thing here is, as the audio plays back, we want to continually visualize the frequency spectrum of that audio using those cubes. So that's the setup for the begin play sequence. Let's start with enabling the player input. If this was something that I was adding as a component to a game, I might do it in a little bit of a different way. I might make it so that player input was only enabled when I was in close proximity of this widget. But here we'll just give the player full input access to this blueprint. So I will get the player controller, and using that, I will enable input. One thing that's funny about this is that it always defaults to the target when I really actually want it to be the player controller that's being enabled here. And just so that we don't need to click once into the screen, I'm going to grab access to the input by setting the input mode to game only. And so then the user will be able on play to immediately interact with this blueprint. That's all we need for enable player input, so I'm going to flag that area as done. And now we can create it so that when the player hits the letter P on the keyboard, search for keyboard P here, and when that is pressed, I want to play some music. You can see here I've set up two different cases. Has the music been started already, or has it not yet been started? And so what we can do is we can grab our audio source right here, and we can test to see if it's playing. So has it started or not? And then I can create a branch that could be fed by whether or not it's playing. If the music's already been started, that's when we want to play or pause. If the music hasn't yet begun, we want to start it playing. So we can, I'll grab another access to audio and I'll just put it in between these two nodes here. I can search for play. And so on the branch, we're testing to see if the music's playing. If that's false, music is not playing, we're going to start it playing. If the music is already playing, well, then I want to flip-flop between whether we should be paused or not paused. And so for that, I'm going to use a flip-flop node. If you haven't used a flip-flop node before, it's effectively a node that has two different states. The very first time you execute it, the execution will leave pin A. The next time it'll leave pin B, and it'll flip-flop back and forth between the two of those. But there's also this Boolean here which tells us are we on A or are we on B? And so I'm going to make use of that Boolean as well to set this audio to paused. And so I'm actually going to make it so both A and B trigger the pause, and then I'm going to use the Boolean to control the pause Boolean. So like the very first time we come through here, A will trigger, setting pause is A will be true, so we will pause our music. The next time through, B is going to trigger, so it will not be A, and so pause will be set to false. And so that should now give us the ability to play the music if it hasn't already been started, and pause and unpause the music once it has been started. So I can flag all of these sections as being complete as well. We can't play or pause any music without first setting a source for that music. And so we can't test this out until we have an audio source. I've already dropped an audio file into my project. It's a WAV file. It's some Creative Commons licensed music. I've put attribution in the description to this video if you want to find that. And so that's what I want to do next, is I want to assign that music to the audio here. So grab reference to the audio. I'll run set sound to set the sound source, and I'm going to promote the new sound here to a variable, and I will just call that variable music. I will link that up like so. And one of the other things that will be handy later on is to know how long of a piece of music is being used. So we can fetch the duration of this music and promote that to a variable called, unsurprisingly, music duration. And now I can flag this as being done. Before we can test that out, we need to set what piece of music is being played. So in the details for music here, I will select that music file. And we should now be able to test whether or not, using our user input and the letter P, if we can toggle the music to play and pause. Perfect. Two steps left. We need to spawn our audio cubes into the scene, and then we need to bind a event to constantly visualize the music as it is being played. So we'll start with spawning our audio cubes. I'm going to create a new function for that. Give it a name, spawn audio cubes. I guess I should call it sound cubes because that's what the blueprint is called. And I want to have a few inputs and a few outputs to this particular function. And so the inputs are going to be the number of cubes and how far apart we want them spaced. And so those will both be, well, one will be an integer, number of cubes, and one will be a float, cube spacing. And once we spawn those into the world, I want to return an array of the cubes that exist in the world. So that's going to be an output here. And so I will just search for my sound cubes. And I will set that as an array. And I will just call it sound cubes. And so that's what's going to be returned from this node. If I go back to my event graph here, we can call that right here. Spawn sound cubes. We want to promote both of these things, both of the inputs to variables. And we can give them some default values. So number of cubes, we're going to set that to 48. And I will explain that magic number in a moment. Cube spacing, currently I've been working with 20 Unreal units for the cube spacing. That cube spacing we can make instance editable, so that's something that could be played around with from our audio source or our audio blueprint in the scene. So here we now have cube spacing that I can play with because I made that editable, instance editable. Lastly, for the spawning of the audio cubes, we want to save the sound cube array that is being passed out to us. So we will promote that to a variable. We'll leave it called sound cubes, and that's going to be an input to the next part of the process. We now need to implement the spawning of the cubes, and so we can go into there. I'll break the return node off for now and set it aside. We want to create number of cubes based on this number of cubes right here. Sounds like we're going to be doing something over and over. That is a job for a for loop, and so I will create a for loop here. The loop body is going to spawn actors of class. Spawn actors from class, and specifically the class is going to be our sound cubes. Those are those glowing emissive cubes that we set up before the screencast. And where do we want to spawn them? Well, we want to spawn them in the world based on the position of where we placed our BP sound cube visualization. And they're going to start where this has been placed in the world, and then they are going to sort of be placed along the y-axis. And so I'm going to get access to the default scene roots location, and I can then make use of that. I'll split the location into X, Y, and Z. Those are going to be fed into the transform right here. So I'm going to split the transform and further split the location. The X and Y can be fed directly, sorry, the X and Z can be fed directly in, and it's the Y that we want to use to sort of spawn out those cubes in a line. And we're going to base that off of the cube spacing. And it's also going to be based off the index of the the loop. Now it looks like I've set this up a little bit incorrectly here. We want the number of cubes to be the last index, and we want to start the first index at 1. And we're not using 0 based offsetting because that makes the number of cubes sort of more naturally flow into the last index here. So it's going to be 1 to 48 instead of 0 to 47. And so based on the index, based on how far we are in this loop, we are going to add to the y. Y is going to get fed in here. And what do we want to add? Well, we want to add the cube spacing multiplied by the index. Like that. And we'll just space some of this stuff out a little bit nicer. Like that. Okay, so that is enough to spawn my audio cubes. And that is complete. We can test it out, and then the final thing we need to do is we need to return the array of sound cubes that we just created. But let's give this a test in the world here. Look at that. There they are. It looks like they're spawning a little bit big. And so let's go back in here and we can set up the scale maybe to a smaller size. We could also scale the sound cube blueprint itself. Let's see if this works a little bit better. There we are. We got 48 cubes spawning in the world. They're all glowing nicely. And we want to return that to the caller of this function. So once this loop is complete, we're going to get all actors of class, looking for our sound cube BP. And that's what we want to return here. Return an array of all spawned cubes. Flag that as done. The very last thing that we want to do is we want to actually visualize them, scale the size or the I guess the height of those cubes based on the strength of the audio within the audio spectrum. I can flag the spawn cubes as being complete here. In order to perform this visualization, this is where we need to bring in a plugin that should already be enabled if you're using a recent version of Unreal. This is the Synesthesia plugin. You can check under Edit Plugins and under Audio to see if you have Audio Synesthesia enabled, as I do there. If you don't, you can enable it. You might need to restart Unreal after that. And so over in my Sounds folder, I'm going to create a new, if I go to Sounds and Analysis here, I want a Synesthesia non-real-time audio analysis component. There are 3 choices here, constant Q, loudness, and onset. Onset is for detecting the onset of particular beats within a part of the spectrum. Loudness is like the overall loudness of the sounds being played. Constant Q is going to do what we want, which is to split the sound up into a number of frequency spectrum ranges and tell us the strength at each of those ranges. So that's what we want, is constant Q. And we'll just call this a Synesthesia NRT constant Q. And if I go into there, I need to specify what sound we want to work with. And it's the same sound wave file that we are playing in our BP, in our sound cube visualizer. So what this Synesthesia NRT is, the non-real time, is it's going to perform that analysis ahead of time and have it waiting for us at the visualization step. Back over here in our blueprint, we want something to happen right here. And so just like I did with spawning the audio cubes, creating a custom function, I'm going to create another custom function here. And I'm going to call it Synesthesia scale cubes. And I want it to have a few inputs, 3 inputs specifically. The first input is the total duration of the music being analyzed, the music duration. And remember, we saved that earlier on. The next parameter is the percentage played, like how far percentage-wise we are in the song being played. It's also a float. And then lastly, I want to take in an array of our sound cubes, because those are the individual items that are going to be used in our visualization. So I'm going to call this sound cubes. So we now have this function with the correct inputs going into it. And over here in our event graph, we're going to go to our audio source. And the audio source has a thing called bind event on audio playback percent. If you think about like the event tick in a regular Unreal application, this is like the equivalent but for audio. So this thing is going to continually call an event as the audio is being played back. And so we're going to create a custom event for that. We're going to call it on playback change. And we're going to just directly call our Synesthesia scale cubes function. This Synesthesia scale cubes function is going to take in a music duration, percentage played, and the sound cubes. Well, look what we get on this event on audio playback percent. We get a percentage played. When we first hooked up the music to our audio, we saved the music duration. And so I can go and grab that and hook it up here. And sound cubes we saved up above as well, and so I can grab a reference to that and feed that in. And so now as our playback progresses, this custom event will be triggered over and over and over, feeding the current percentage into our visualization function. So the last thing is to just implement that function. In this function, we need to do 3 things. The first thing we need to do is we need to calculate the current playback position in seconds. So that's going to be step 1. Sort of that's going to be based on the total duration of the music and how far we are currently into the song. We're going to get the current position in seconds. Then we're going to go to our Synesthesia NRT, and we're going to ask for the current breakdown of strengths in our various frequency bands. And so this next section is going to say save frequency band strengths. We're going to get an array of frequency band strengths. And then finally, we want to scale our sound cubes to those frequency strengths. And that'll be a fairly big thing to do. We have a sequence of things that we want to accomplish in this function, specifically 3 things that we want to do here. The first of which is to calculate the current playback position. This is just going to be the music duration multiplied by the percentage played. Float times float. Hook that up. Promote this to a variable called position in audio. We can hook that here. We can hook that up like so. Try to straighten all these wires out. And just route around here. All right, that step is done. Next up, we want to save the frequency band strengths. And so it's at this point that we want to bring in our synesthesia analysis. And so there is a node. I'm going to turn off context sensitivity here and search for get normalized constant Q at time. And we will promote the target to a variable here. And if I compile that, we can set that to our synesthesia constant Q that we created earlier that we've linked to our music file. And we will just call this our synesthesia analysis. Okay. And so with that synesthesia analysis, we are getting out a array of strengths. And so what you can think is happening here is that the synesthesia is analyzing the sound that's currently being played. We're going to feed in sort of how far we are in our audio. So we'll take this position in audio and feed that in as well. And it's going to give us out a array of floats. And so what it's going to do is it's going to break down the audio spectrum from really low sounds all the way up to really high sounds. And for each range of sounds, it's going to do 48 different ranges. It's going to give us sort of the strength of that particular frequency band. And the 48 is coming from the default of synesthesia itself. So if we go in here and we just click on the settings, you can see the number of bands is defaulting to 48. And so we'll just leave that number, but you know, that's something you could play around with if you wanted more or fewer bands for the sound analysis. And so I'm going to promote to a local variable that array of floats, and that's going to be the frequency band strengths. Frequency band strengths. That's what's going to be done next in our sequence here. That can be flagged as done. And now we want to take those frequency band strengths and link them up with our sound cubes. So we want to loop over each one of our frequency band strengths. So we'll use a for each loop. We can hook this up as the next item in our sequence. like that. And then on the loop body here, we want to pair up each one of our sound cubes with a particular index of our frequency band strengths and scale that sound cube's height. And so just to make that a little bit more obvious, what we're doing here is if I hit play here we have, these are going to be, the high sounds are going to be represented by this end of our sound cubes. Low sounds will be represented down here. So when the kick of the drum comes in, we'll see these scale, like so. When higher notes are happening, these are going to scale. Each one of these sound cubes is going to represent a different frequency band that we're getting back from synesthesia. And so we have 48 frequency bands, we have 48 different cubes, so we can take the index of each one of the frequency bands and match it to the index of each one of the cubes. So the cubes are coming to us from the input here. I can feed that down below here, and I can just say get, I'll put context sensitivity back on, get a copy. And we want to get a copy of each, or get a reference to each sound cube based on the index of the frequency bands that we're looping through. So we'll feed that in there. That's looking good. That's being fed in. There we are. And then with that, we want to scale, set world 3D scale, and we want to specifically just scale in the Z direction, right? Z is our up and down, so that's going to, that's where how we want to scale those cubes. So I'm going to, with this set world scale, I'm going to break that struct out. The X and Y scaling, we'll play around with those. I think we had earlier had them scaled to 10% of the size of the cube, so that there's just going to be constants coming in there. And then we're going to hook that in. Each array element is sort of the loudness or the strength of this particular frequency band. We're going to multiply that by a scaling factor. So I'll just create a new variable that I will call scaling factor. We can initially start this as 2. We can make this instance editable, so that's something that could be played around from within the level itself. And this is going to go right into our Z scale. And I think that's all we need here. We calculate how far in seconds we are in our audio. We grab the frequency strength bands at that particular position in the audio from synesthesia, and then we loop over our frequency strengths using each one of them to scale a cube that matches the index of our frequency band strengths. Let's test that out, and then we can mark it as done if everything is working. Look at that. So we'll just go in here and we will mark this as complete. And we'll do a very quick review of the overall process of this blueprint here. When begin play first executes, the blueprint has a sequence of 4 things it does. It enables the user input, giving the user the ability to play and pause the music using the key, the P key on the keyboard. The audio component on the blueprint is assigned the music that we have imported into our project, and we grab access to the duration of that music in seconds. We spawn out the audio cubes using our custom function, spawning them out based on the default scene root location of our visualization blueprint, and scaling their placement based on the cube spacing that's coming in here. Currently spawning 48 cubes from the outside world and returning an array of those cubes back to the caller. The caller saves those in a sound cubes array. And then the very last thing that is set up on begin play is that we set it up so that as this audio is being played, we are binding an event such that as the percentage play changes, we're going to continually call synesthesia scale cubes with the overall music duration, how far we are in the music in terms of a percentage, and with access to the sound cubes. And then it's within there that we actually get our synesthesia strengths and scale the cubes based on the sound. Let's look at this visualization one last time. I want you to think about potential uses as game mechanics here. You could think about, puzzles where you have to run through a field of these. Maybe you can only get by when the music is quiet, and when the music's loud, you can't pass a particular part of the level. You could even think of having larger version of these cubes that the player runs across, and as they're running, the staircase in front of them rises and falls based on the sound of the music. There's lots and lots and lots of possibilities, but here's our final look at the visualization that we built.